and thank you all for being here. Today we're going to introduce you to the veteran you never had the chance to meet. This little guy is called Superfetch, and trust me, he knows more about you than your closest friends do. Before getting acquainted with him, let us introduce ourselves. I am Mathilde, Venault, a master's student, and this is Baptiste, a PhD student. We both work at the ESIEA laboratory in Laval, France.
If you have one day wondered what means standby memory in the resource monitor, we might have a solution. Actually, this memory is composed of preloaded process and preloaded file, even if you never ask for this process to be launched or this file to be touched. How is it possible that the system preloaded something in memory, even if you didn't ask for it? Actually, the system tries to guess what you are going to use. But how is it possible? There is in the system a little spy, which spies on you every hour of every day. Its name, System Service.
This service tries to make your life easier, actually, by two leverages. The first one is optimizing the boot, and the second one is analyzing your daily software use so it can predict and prelaunch what you might need next time. For instance, if every day, as soon as you turn on your computer, you go to your web application, well, tomorrow morning, your OS will be ready to execute this application before you even think about it. But to clear things up, Superfetch is just a part of the sysmain service. But the misuse of language is often made because until Windows 8, the whole service used to be called Superfetch. The place of sysmain is located on C, Windows prefetch, and there are many things in this directory. You first have a directory called readyboot. This is related to a driver's activity called readyboost. You have the majority .db and the .pf files. They are the traces of the course activity. And you've got a file named layout.ini. Let's have a closer look at it. This is a list representing the best order for your OS to load files when booting. And of course, it begins with the kernel, because without him, it won't be able to load much.
Yes.
The rest of Superfetch performance is based on reducing memory operation. But to understand this concept, we first need to make sure everybody knows what is memory paging and how does it work. So, every process is divided into pages, which are same-sized block of data containing the instructions of the program, etc. And those pages will be mapped usually into the RAM, which is the physical memory, but they could also be mapped into the virtual memory. Every process has also what we call a page table, which is an array associating the page number, which is the index of the physical address, to the frame number, which is the index of the virtual address into the physical memory. When you launch the program, the CPU has to first figure out where the instruction is. So it goes to the page table with the page number, gets the frame number associated, and then executes the instruction. But what would happen if the page is not mapped into the physical memory, but into the virtual memory? Well, the page table can't resolve the address of the frame number since the page is not mapped into the physical memory. So a page fault occurs. To deal with that, the OS will first find the page into the virtual memory, then it will bring it back into a free frame, and then it will update the page table with this new entry so the process can be done again. The whole point of Superfetch is to avoid this whole process of handling page faults, because they are not errors, they're just normal parts of memory management, but actually they do require times and memory operations, so they slow the system. To avoid that, Superfetch references the page accesses, the page faults, so it could directly map into the physical memory the page faults that happened once, and to avoid them to happen again.
Let's check how it works. Superfetch, or sysmain service, is composed of different components, and among all these components there is 5 very important ones which are called agents. So we are going to focus on introducing every agent. The first agent is called agent context, AGCX for short. This one is based on user information, that's why it's dealing with seed and token of user. It's main focus is concentrating on context change, which means when the computer is going to hibernation, when the computer is going to standby mode, or when you are changing session. You have two ways of changing session. The classic one, which is disconnecting from your current session, going to the new session, and the lazy disconnect, which means from your current session, going to a new session. Directly. And what's happened is when you are changing the session, actually this agent is going to take a snapshot of your session, so that when you are going back from the new session to the original one, this is that snapshot, which is used to improve the performance. The second agent is agent pfndb for page frame number database, which is a very important agent. This one is going to focus on two information. It is allowed to log every page fault to know which file does matter for a given process, and it is allowed to log every access to memory page in a process. So from a working state of many pages, all these pages can be in different lists: modified list, standby list,
free list,
zero list. All of these pages are actually monitored in a way by this agent, so that it can guess or know which page matter for a process, which means if you have loaded a file in memory and this file is not accessed a lot, it doesn't make sense to keep record on it. But if that file loaded has a lot of access by memory for a given process, it makes sense to keep that information. And in addition, it adds tags to the page of memory which are tracked in memory. Is this page private memory? Is this page shared memory, committed memory? Or if this page is coming from a backbone application or foreground application, making sense that the backbone application does not need the same responsiveness, the same ability to be running fast, rather than a foreground application.
They're not going to be processed as the same way because the needs are not the same.
Yeah, exactly. And we have another agent which is important, which is upload agent. This one is responsible to monitor every process, to be notified that this process is using that file, etc. And actually, from all this information provided, is making statistics with a Markov chains process to define pattern of use from a memory point of view of a given process. But approach is very focused on every process. It has not a global view. If we want to deal with agents with a bigger view, we've got a robust performance agent, AGRP for short. This one assures the relevance of all the databases which are recalled. Actually, it's not an average of the system.
Yeah, it calculates like a threshold to make a mark and calculates if a file is relevant or not.
Yes, actually, let's suppose you have on the system software you are using during 3 days. It makes sense as the fourth day that the system is guessing that you are going to reuse it. So it's going to preload it in memory so that when you are launching the software, it's much faster. But let's suppose now, after 3 days of intensive use, you are no more using that software anymore. After 1 week or 2 weeks, Superfetch and robust performance agents is about to guess that this software is no more relevant to be preloaded in memory. That's why we should remove it from the preload list. So this is its role. Another agent which is very central and which has not really defined goal, except supporting other agent, is global agents. This one is very important because it manages a lot of things like histories. Histories, it's a collection of scenarios file, and scenarios file, for short, this is the way that Superfetch is predicting which page could be used by a given process, etc. So scenarios are very central.
Yeah, they're really important into the heart of activity.
Yes. And it defines phase per day. So this is a service which tries to know how you live with your computer when the morning starts.
Yeah, what are the schedules for the nights?
Yeah, for you, for your use, and is able to check to guess that if you are in a working day, you are supposed to use that software, but the weekend maybe you are using video games or stuff like that. So that is going to change for Saturday and Sunday how you are going to use your computer so that you can preload what makes sense for you during weekends or during morning or evening. So this is an agent which knows you very efficiently. Reusing prelaunch, this agent has two sides. More than just statistic, is the agent responsible to preloading memory. For short, making the page in the standby list. So that's for all the architectures of the different agents. But agents have for all of them different tasks. The prefetch routine, for sure, which is a part of the system, collecting statistics, making prediction, all these scenarios. Yes, updating scenarios. So this is non-stop jobs. But there is also different jobs. One is about saving. Makes periodic saves. If you are going to check on internet, you can read sometimes that these saves are performed every 3 days. Actually, it's fake news. Because all the save depends on the type of the data, string, date, user activity, etc. It depends if it's registry key, database, other file, etc. And it can be controlled by registry values. Yeah. So it's far to be accurate to say it's every 3 days. Another task which is relevant is idle task. It means under specific circumstances, low CPU use, low memory use, consumption.
Disk use as well?
Yeah, and when your computer is about to do nothing, Superfetch is taking the hand to perform highly resource consumption tasks, like updating optimal layout, making math, making defragmentation of regular hard drive. So this is very interesting task, but these tasks are only performed if it's power supply for your computer, which means that if you're on a laptop, because this is a highly resource consuming task, Windows doesn't want to decrease the performance of the autonomy of your laptop. So that's why if it's power supplied, only all these idle tasks can be performed. Another fact, which can be fun in a way, is that Superfetch is using more than 22 registry keys and values to make communication or synchronization with the driver, which is supplying it a lot of information, which is powerful. These keys can be used to exchange data buffer, strings, or just for synchronization, creating one value, deleting the value right after. So this is not the usual way of communicating with drivers, so that's a bit fun.
Maybe it could be due to retrocompatibility, we don't really know, but it was kind of surprising.
Yes, but that's true. Another thing is that Superfetch has 5 different types of database. From all different agents collecting different information, even if this is different information in their shape, in their data, they are all stored in files which have the same format. Technically speaking, Superfetch in this main service is using a set of internal functions, sort of internal API, if you want, which are collecting from different information, processing all this information so that they can be saved in the same shape of file and the same format of database. So on these pictures we made the links between the different internal functions which are used to perform all these tasks.
This leads us to another pillar of Superfetch, which are its prefetch files. It includes the .db and the .pf files, and the first thing you need to know about them is that they're almost all compressed within the documented function RTL compress buffer and with the Express-Huffman algorithm. But it was not always the case, and it used to be SZNT1, so it might as well change in the future. Let's first focus on the database files. They are the .db and they are related to the agent's activities. Actually, they are the way for Superfetch to rebuild the internal database for the agents. So one agent might have more than one .db associated, since one agent might need more than one DB for its internal operation. Please note they are not always present on the directory, which makes them really much more complicated, and this might also explain why their format was not documented so far. Their name hasn't been explained as well, so here is a list of what we could come up with. So we've got the AGCX, which is followed by a huge number actually.
This number corresponds to the seed of the user you have on your machine.
So you may have more than one if you have a multi-user machine. You have also the AGGL file, which is followed by some abbreviation. You have the FG, which refers to foreground application, as we say, they do matter to know where the have come from. You also have the UAD, which actually might refer to user active days, but unfortunately we do not have a means to check that, so this is only an assumption. So as we have seen previously, all the databases are connected to each other, so they follow the same reading process. For each file in orange on the screen, the reading process is divided into 3 steps. The first step is, if required, getting the view of the file, decompress the buffer. Then you've got the initialization of the internal database in dark blue, and after that you fill the data. Superfetch fills the database with the information contained into the file. Regarding the database itself, when you open it, you first see the compressed format. So this is a buffer with a magic number specific to Superfetch files, and then the decompressed size and the checksum to make sure there is no data corruption. When you decompress the buffer, you have many informations. Among them, the most important are the header size, because the header size is useful to calculate offset within the file. So without him, the offset calculation do not mean anything. And you've got the database parameter file type. Sysmain has an internal table of 16 sets of 8 numbers, which are the parameters. The file, parameter file type, shows actually the index into this table to find the corresponding parameters. And those parameters have 2 major uses. The first one is offset calculation within the file, and the second one is setting some sizes into the internal database corresponding. So the details of the calculation within the files are just in here. The pararound 1 is useful to calculate the beginning of string 1 from the end of the header, and similarly, the pararound 2 is useful to calculate the beginning of string 2 from the end of string 1.
So from all the data stored in this DB file, Superfetch is about to create something much more involved, like scenario files. So from all the data collected from the system, is going to process all this information so that it is able to make guess of what should be preloaded, what is used by this process, etc. To do so is going to create scenario files. Scenario files have always the same shape of name. First, they are stored in C Windows prefetch directory, and then this is always the name of the app.exe dash 8 digits and pf extension. Actually, they are traces of an application, and one application can have one or more scenario files depending on the context of the execution of the given application. One interesting thing is that this directory and these files especially are ruled by key in the registry, and especially values in that key. Among the values which are present in that key, which is software, Microsoft, Windows NT, current version prefetcher, there is a max prefetch files key, which is by default set to 256. Which corresponds to the maximum number of scenarios files which are stored on the disk. And for each file, there is a key which is max prefetch file size, which gives us the maximum size in bytes of a file. So this is a way, by multiplying the 2 values, to know the maximum size that Superfetch can use for scenario files. So once we know that how are managed scenario files, we can try to understand how they interact with Superfetch. Let's suppose that a program is launched, so it means that a process is created, and in a way or another, there is a notification performed by the operating system, FileInfo if you want, to explain to Superfetch service to transfer this information that a new process is created. From that process created, Superfetch is going to check if it exists for this process scenario or not. How is it possible? Simply by just requesting if the file already exists or not. So it needs to know in which context it has been launched. First, Superfetch is notified with the full application path, and in addition, parameters provided to that application. For instance, you have a command line like
the
defrag.exe, and you can add the parameters like dash s dash b, stuff like that. So all these parameters are provided to Superfetch, so that it's a long string, and from this long string there is a sort of hash function. Actually, this is far from being cryptographically secure hash function. It's much more like homemade hash function, so it's just a linear transform of every characters. Interesting, on Windows 10 version we have reversed. This is based on a string constant, which is pi constant, which is 3.1415.9, etc. And so this is interesting, but it doesn't correspond to older version of Windows. So from time to time, this algorithm has changed.
Yeah, there were some modulo, some other operation, or some difference depending on the value of the seed, etc.
So, what is happening when there is no file? Actually, Superfetch is about to create a new file if there is no one created for given scenarios. But if there is one, Superfetch is about to read information. Actually, it reads only relevant information from him for him in that file. Then, taking into account we have access to scenario, we need to know how to provide new information, because your process is running, and since it's running, things can happen, and all this activity can be monitored to enrich the content of a scenario. To update, this is done via the kernel land component, which is FileInfo, which is a file mini-filter driver, which is the evolution of legacy filter driver for file. Its main job of this driver is to provide name and information, mostly read-write or name change operations, stuff like that,
locations,
about different files touched by all the process of the system. So how is it possible? For the sake of simplicity, we can explain that in the mini-filter driver technology, you can add context to each file for when you have a create notification of a file or access a file if you prefer, or removing the context when the file is no more used, so that when there is a read or write operation, the context is used to know that this is that file which is targeted. And doing that, this driver is about to record which part of a file has been read, which part of a file has been written. So this is a lot of very relevant information for Superfetch to know what should be loaded from file, not the full file, but maybe some relevant part of the file. So it really makes sense. And from all this information, from time to time, FileInfo is going to give back all this information to the sysmain services. And checking from Windows public debug symbols, this buffer is called NL buffer.
Yeah, unfortunately we do not really know what does it mean, but we can assume it's normalized something.
Yeah, and it should be for normalized, yes. Works, actually. From scenario files, actually all this data is processed to be stored in scenario file, which owned by PF suffix, as explaining. Actually they are managed almost the same as the database, so it means it's compressed. And if you decompress them, you have a lot of relevant information, OS version, prefetch signatures, and you've got the name of the application. In our example, we have decided to use VLC, which is a media movie player, and so that's why it's written vlc.exe. We have a lot of information which are relevant. One which is very relevant from a forensic point of view is the last date when this software has been used, so that we can know exactly when you are using your software, morning, evening, or which day, the frequency you are using it. So it might be interesting.
Yeah, also what you have done yesterday and the day before, and all of the stuff, so all your schedule actually.
Yes, this is very good to spy on you. Well, you have also the number of times it's executing, but more interesting, you have the file which has been touched by your application. There is different rules to be recorded in the scenario files, because not all files are recorded. First, because it's for optimization purposes of the speed of your computer. The executables load every time they are DLL. So a lot of files recorded in scenario files are DLLs of the given process. But you've got also recent files, such as personal file. In our case, this is a very famous movie that has been recorded directly in the scenario file, so that we know exactly which movie you have watched, and combining with the information from file info, we know exactly which part has been read from the file, so from the movie. So it means that we can know which part do you prefer, or have you finished to watch that movie, etc. So this is very relevant information about you, but there is more.
And actually it works also with the songs, the photos, the text documents. We also have the names of the directories, the names of the files, so it tells everything about you. You also have the cache files. This is really specific because they are the result of the cache memory management. You have the example of the reference with the directory of the cache. The cache for the record is a memory management that aims at storing pieces of data to reduce their access time later on. It is also designed to do stream caching, so this implies the data stored could be the contents of the file.
Yeah.
And here's the proof. We have updates. This is a .txt document, and the content of the document is written in clear text. So this is a nice way to find your personal contents from any text document, actually. Superfetch does not have the content, but it shows you the way to do so. So let's sum up. Now you know what is sysmain and how it works. You know
which file you are using.
Yeah, and what is interesting to extract from that, the count of execution, the dates, the times, the names of and locations of each file, etc. So from a forensic point of view, this is a wonderful opportunity to track any user. But it also means that you could be a victim of that. So what if you want to protect yourself from it? Well, it's our pleasure to announce you it's time to fool your OS. The first step to do that is to find a way to access to the data. In 2010, Nearsoft has released a tool named prefetch View that allows you to have an overview of the prefetch scenarios, and you can see the details of each scenarios in it. This is really user-friendly, and this is really useful to have this overview. But when we used it, we faced 3 problems. The first one is the tool is closed source, so you don't really know how the data is processed.
And you cannot change if there is an update in Superfetch.
Yeah, so this was one of the major problems. The other one is the information is only about the .pf. So even if the .db do not reveal much about your habits, such as the scenarios, they do matter. And this was something bothering us.
Yeah.
And last but not least, you can't edit the data.
So it's read-only software.
Yeah. Mm-hmm. There is no way to change what the scenarios reveal about you, etc. And this was the goal. So to solve these problems, we have created our own tool in C that allows us to have the full control on any kind of prefetch files. You can compress, decompress any buffer, you can view the information, and you can edit the information. Of course, this is open source, and you can also hash with the Superfetch 10 algorithm. But what we are really interested in is fooling your OS and fooling sysmain. So the roadmap is pretty simple. We will pick any program scenarios. We will open its scenarios, decompress it, edit the information, and then we will compress it, save it, and reintroduce it into the prefetch directory.
Demo time, maybe.
Yeah.
Let's do the demo.
So this is an example with PowerShell. We execute
PowerShell once.
Yeah. We get the scenarios, copy and paste it elsewhere in the prefetch directory. And then we open it with our tool. So it offers you to decompress and view the information. So we've got the information we talked about, the count of execution and the date. It's currently the 26th of June and it's 9:32. So let's try to change this date. Okay, so we open the decompressed buffer. We set the right offsets and change the date. So let's say it's the 14th of May. Okay, we save it. We compress this new buffer so it could be reprocessed by sysmain, and we put it back into the prefetch directory with the original name.
So that it will erase the original file.
Yeah, and let's see how the OS reacts. put it back into the prefetch, replace it. Okay, now let's launch once more the PowerShell to see how the scenario goes.
So let's launch PowerShell. Oh, great. And let's check what changed in PowerShell scenario.
We copy and paste elsewhere as the last time. We open it with our tool and let's see the information. Here it is. You've got the date falsified and the OS didn't realize it has been falsified, so you can wipe any traces with that.
So we can full forensic tool based on Superfetch.
Yeah, your OS, any forensic tool, because the OS doesn't notice that. So here is a way to protect yourself and fool the OS and trick everything. But what if you want to completely prevent yourself from any system track? Well, actually, Windows internals would advise you to edit the registry value called enable prefetcher and set it to 0. But let us show you what we have seen. Okay, so we open the registry and get to the values.
So normally the two values are set to 3, which means enable.
Yeah, directly. So they are set to 3. When we launch Notepad, the scenario is written as usual.
So we are going to remove this value to 0 so that the service should be disabled.
Let's reboot the system to make sure the change has been taken into account.
Rebooting. So we have accelerated that part because it's going to be a bit slow.
Yeah, it's pretty long.
And here we're back. So first we are checking in the registry that the two values edited are still 0. That's the case, right?
Right.
Going to prefetch directory. Okay, this is 0.
And now we will try to relaunch Notepad as we have just been doing before and see what happens.
And surprise!
The scenario is still updated, so it means the system didn't stop actually.
No,
even with this value. Another example is the function from sysmain, pf as the superfetch check and enable, and even though the name speaks for itself, let's see what the function is doing. So it opens the registry key we have just seen, the enable superfetch, and it uses the reg set value to set this registry value to 3. So it actually doesn't care about the initial value, and at one moment in Superfetch, the enable Superfetch value is going to be 3 again. So these values do not have any impact on sysmain activities. To be honest, the solution is quite basic. You can disable sysmain manually through the service control manager or any command line. But please keep in mind that it's going to cost you performance, because even though sysmain tracks you and knows you and your habits, it gains performance.
Actually, it's like the first time you have installed your operating system, you see the same performances, so it's not so slow. But you don't get access to the improvement of performance provided by sysmain to keep your privacy. It's a bit like when you have a web browser and you want to use it in private mode. This is exactly the same, actually, but for your old operating system.
We really think we have contributed to the comprehension of sysmain, and we are glad to have built a tool that exploits these functionalities, and we would be more than happy to have your suggestion. If you experience it on your own, you can download it on our GitHub and contribute if you have any suggestion. It would be really welcomed. We also think it would be really rewarding to go further on the interactions with the drivers, such as file.info, and also dive further on the Windows cache, because it hasn't been explained a lot. So who knows, we might find more about your personal content. Thank you for your attention, and if you have any question, it's time.
It has been a great time with you.
Hi guys, it's me again. If you have any questions, it would be my pleasure to help you.
Hi. So we have answered questions in the chat, notably if the GitHub link will be provided. So there will be, it's present at the end of the slide. But if someone needs it, we can maybe post it on the chat directly.
I will post it.
There was a question about malware detection. Yes, please. So yes, there was a question about malware detection. Yes, actually, Superfetch can be used to do that. You can make malware detection with that easily, because most of malware don't think about to avoid Superfetch to detect yourself. So this is a great way from a forensic point of view to make the detection. So okay, I'm reading the chat to have questions. Yes, you can edit the DB file directly with our tool. So this one is open source. So if you want to contribute and modify and improve it's no problem. Actually, yes, you can modify a lot of file. The most interesting are scenarios directly, but yes, you can modify also DB.
Yeah, there is. I just posted the GitHub link. Actually, I will open it to the public in a few minutes. But now you have the link.
What exactly can you change in prefetch file? Actually, we can change a lot of things, like name of the executable, the time when it has been used, the number of time it has been used, and the file it has been consumed. So the file which has been touched by your application.
You also have all the information we have seen on the header, such as the time executed, the count of execution. So it can tell us a lot about you. Like if you have a malware, let's take this example, and it has been executed just once, well, you know that it's not likely to be launched again, and all of those stuff about your habits and your usual programs.
And actually, there is no way for one to know that the Superfetch files has been modified, even if it's randomly modified. So security is not very present in the file. It's just regular files that you can edit. Once you know how to read them, this is a gold mine. And yes, we have reversed the hash, actually. And but the hash is it's a losing data hash. It means you cannot, from the hash value, retrieve the original strings. But that's not a big deal, because actually this is far to be a cryptographic hash. You can perform, if you want, collision very easily, just a linear transform. And yes, the GitHub links may have issues. We are going to open it and make it available as soon as possible.
It should be fine now.
I'm going to test it.
Yeah, let me know if there is still an issue.
Yes. Actually, that's a very good point for us, and we would have preferred to be present physically, but is the link available?
Yeah, the link should be working now. Let me know if you still have it.
Now. Perfect.
We have one more question. Does the Windows system record that the scenario file has been randomly changed? Actually, not at all. That means if you re-inject the file you have just modified, but with the original name, that's to say our tool allows you to change the file, but the extension, just before the extension, you will have like result compressed to tell you if the file is compressed or not, and if it has been modified. Well, if you re-inject this modify file into the prefetch directory, the OS won't notify it, and it will Windows will process it as any other prefetch file. And that's the magic part of it. Control your system.
So there is two. We will try to To answer them first, disable Superfetch, yes, it's like being privacy mode in web browser, so it's for the full system. But yes, that's a clue that you know that Superfetch is enabled and you want to avoid forensic. And the last question, does malware have the ability to inject itself in Superfetch? Well, actually, Superfetch is running with system privilege, which means you have to be administrator of the machine. And so once you are administrator, you are on the other side of the AirWatch. So it means the security is already broken. So, but yes, if malware as administrator writes, you can disable Superfetch or full Superfetch by itself. Yes, of course. So we hope you enjoyed this presentation. We enjoyed to do it, and thank you for your attention.
Yeah, if you have any question, you can contact us, and it would be a pleasure to answer.